So,
Is it on now?
yeah, it's on.
Hey!
Kendra says aye.
I did. Big picture. Oh, should we be writing this down?
You don't probably need to. Okay, so remember, here's how you can deal with the notes. I mean, it's probably not a bad idea to write some stuff down just to have it immediately available. But I do update these every day, right? So if you go to Moodle, the PDF is up every day of what we do. So the big picture here is solving quadratic equations. Okay, and I'll talk a little bit more about that in a second. Today, we're going to kind of build up to that with some skills. Okay, so we're going to look at how, if we wanted to take simple quadratic equations. Let's get everybody, I want all these closed. All the closed got to click all the way closed. So if we want to solve the simplest kind of quadratic equations, and let's just take a quick example. Like if we had something like, let's say, what we got here? So, yeah, I gotta think for a second. Okay, that ought to work. Okay, so how would we solve this thing? Okay, I'm hearing add 7. That's good. And that's going to give us negative 3x squared equals negative 24. Now what? Divide by negative 3. Good. And that's going to give us x squared equals 8. Okay. And then last step. Well, I guess here, before we do the last step, how are you getting these steps? What are you really doing without even maybe thinking about it? PEMDAS backwards. Good, because we're isolating. So this is an example, and we said earlier in the year, and I'll say this many more times, if you can point to a single x in an equation or a single variable, you can always isolate it by just reversing PEMDAS. Now, having said that, there are a couple weird cases that we'll deal with, like piecewise functions and some where things kind of get messed up. But for a normal function, like most of the functions we're going to deal with, quadratic functions, polynomials, rational functions, things like that, this is always true, okay? And all we're doing here is just reversing PEMDAS to isolate the variable. So we, obviously we added to both sides, then we divided, and now finally we're up to the exponent stage, and there's my exponent. How do we undo squared? We square root. Square root both sides. And so we get the answer, x equals what? Square root of 8. Okay, for now we'll just leave it like that. Is that true?
Yeah.
Partial credit. Partial credit only. No, I don't. Okay, and I don't even care about simplifying it for now, but it's still partial credit. We've only got half of the answer there. What's going on?
Oh, yeah.
Plus or minus? Yeah, plus or minus. Okay, so why do we need the plus or minus?
It could be either one.
Okay, now we gotta be careful with this. What is the square root of 8? Or let's do a simpler one. Let's take something like the square root of 9. What is the square root of 9?
Plus or negative 3.
It's not. It's 3. The square root of 9 is 3 only, but that's different than saying if I have x squared equals 9, x could equal plus or minus the square root of 9. Okay, you see the difference? This is a really common misconception. When you take the square root of a number, you get one answer. But if you're solving an equation where you square root both sides, then you have to include the plus or minus, because what are the values that I could square and get back 9? Well, there's two of them. There's the square root of 9, or its opposite, -3. See the difference? So you don't include the plus or minus. If you're on a test, where it just says, what's the square root of 9? If you put plus or minus 3, that's wrong. It's 3. But if you're solving this equation, solve the equation x squared equals 9, then the answer has to be plus or minus. Okay. I will prove this to you mathematically, why this works, a little bit later. Okay, but for now, just think of it as the fact that, just remember this by the fact that you could square a positive or a negative value of that variable, and they're both going to be positive. Technically, this is called the square root property. And here's kind of a way to summarize it. If you square root both sides of an equation, an equation's important, right? We're talking about an equation here. Then you must include plus or minus in your answer. Okay? All right, but let's go back to the problem we were doing. Okay, the problem we were doing was plus or minus the square root of 8. And so that's not fully simplified, right? How do we simplify that? I mean, you guys knew the answer. I heard people saying 2 radical 2, right? 2 square root of 2. So that's our final answer. What we want to do today is I want to, maybe we'll get to this part where we're solving these kinds of equations. Maybe we won't. We'll just see how far we get. But I want to get to the point where we're capable of doing answers where the radicals are completely simplified, but for numbers simpler than 8, right? You guys I know you've done this, but I don't think you probably spent a lot of time on it. Okay, so to do that, we need to build up or remind ourselves about some of our factoring skills for numbers. So if we take something like, if I tell you to do prime factors, where is this? Did I? Oh my gosh. All right. Where are we here? Okay. Okay, so what if we want to find all the prime factors of the number 2520, 2520, and write that number in prime factor form? How do we do that? How did you guys do it? Have you ever used a factor tree? Okay, I think a factor tree is a good way to do this. So if we start with the number 2520, we're just gonna build this. We're gonna break this into branches of our factor tree until when we get to the end of each branch, we end up with all prime numbers. Okay. So what's one number we know goes into 2520? 10 does. Okay. So for one thing, we could break this into 10 times 252. Right? What does 10 factor into? 2 and 5. Okay, and we're done with those, aren't we? Right, those are both prime. What about 252? I mean, there's no one way to do this. You can either, if you think of big factors that it breaks into, great, but what's one obvious factor in 252? 2. It's even, right? So we know 2, and what's that gonna give us? 126. Okay, so the 2's done. What about the 126? 2. And 64. Right, yeah. 64 is 8 and 8. Did I do that wrong? 63, there we go, yeah, thank you. I didn't seem quite right. There we go, 63. What about 63? 7, which is prime, and 9, and 9 is 3 and 3. So there's all of our prime factors. Now, if we write these in order, right, from the smallest to the biggest, I've got, so this is equal to 2, we'll just cross them off, times 2 times 2 times, we got a 3 times a 3 times a 5 times a 7. Okay, but we don't want to write it that way. That's a long string of numbers. We can summarize that. That's not simplified yet. How would I write 2 times 2 times 2? 2 cubed. Times 3 squared times 5 times 7. That's our answer. Okay. This is good. This is a better way to do it because now it tells us what all of the factors are, and then the exponents tell us that's the multiplicity. Tells us how many times each of those factors appears, right? Okay, make sense? Okay, so real quick, open up your Chromebooks. I want you to do, I'm going to throw up an assignment for you to just do a couple quick practice